Alright, so as I was stating, just make sure that the person, whoever is in charge of managing the computer, goes up and moves on to the next video. So again, we were looking at y equals x squared. Now, that is a parabola that is opening upwards. This is a function that you should already know or be familiar with from Algebra 1 and Algebra 2. It is a quadratic parent function. Now what I'm going to do is I'm going to go ahead and graph negative x squared, which I hope you know what that will do to your picture. And I'm going to go ahead and zoom out. That is still a parent function, but as you can see, the parent function, the one that we started off with, that was the one that's in red, opening up. What actually is happening now is that with negative x squared, that's actually, it has flipped it across the x-axis. So in other words, it has just flipped over downwards, and it's now a parabola that is opening downwards. So if we apply the same concept to the parent function that we were looking at here, y equals negative sine of x, that means that everywhere we see I call these right here humps, and I call these over here dips. So now everything that is a hump will flip about the x-axis and will become a dip. Likewise, everything that is a dip will flip about the x-axis and will become a hump. So basically, it's as if I have taken each of these points here and I've multiplied it by a negative. Do you agree that right in front of this negative, or right behind it, is a 1? You don't see it, but it's right there. So basically what this is saying is you're going to take each of the magic numbers from sine and you're going to multiply it by a negative 1. And when you do that, each of those numbers will give you a new set of points that you will plot, and it will give you your function that is actually in orange right there. So as you can see, as I mentioned, when you flip the original, this is the original dip, and once it's flipped, it has now turned into a hump. And right here, this hump is the original hump, has now turned into a dip when you have negative sine of x. Okay, now what we are going to do is we are going to go ahead and graph the cosine parent function. Again, it's a trig, so it's going to be some kind of wave. Remember that sine and cosine are sinusoidal waves. So we're going to go ahead and again have some magic numbers from cosine. So if we review, we had magic numbers for sine, and those were 0, 1, 0, negative 1, 0. Remember them, 0, 1, 0, negative 1, 0. And those were for the values 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now let's go ahead and create a chart for cosine. I'm going to give you a couple seconds to go ahead and write it down. And again, notice that these right here are the same values from your unit circle on each of the on the x and y axis. 0, pi over 2, pi, 3 pi over 2, and 2 pi. If we were to convert these in degrees, which you should know by now what they represent in degrees, this is 0, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Those magic numbers, so if we were to plug each of these values into my parent function, so if I were to plug in the first one, cosine of 0, well, cosine of 0 will give me 1. Plug in the next one, cosine of pi over 2. Cosine of pi over 2 will give me 0. Cosine of pi will give me negative 1. Cosine of 3 pi over 2 will give me 0. Cosine of 2 pi will give me 1. Those magic numbers for cosine are 1, 0, negative 1, 0, and 1. So I'm going to give you a couple of seconds to go ahead and finish writing your chart. And just as a review, notice that these values here are what unit of measure? What unit of measure are these values here? That's right, they are in the radian unit measure. And my next question will be, how do you know they are in radian measure? That's right, because you see a pi. That is exactly correct. You should be able to now identify why, or how do you know if it's in radian, and how do you know if it's in degrees? Very simple. If it's in degrees, we are going to see the little degree symbol. If it's in radians, we're going to see the pi. Okay, so if we're going to graph this one, again, go ahead and create your x and y axis with the new set of labels, pi over 2, pi, 3 pi over 2, 2 pi. And then on the y-axis, it's going to be -1 and +1 over here. Likewise, the negative values will be on the left-hand side. Now remember, when we plugged in 0, it was cosine of 0, and that gave us a value of 1. So that's what I'm going to plot there. When I plugged in pi over 2, it gave me 0. When I plugged in pi, it gave me -1. When I plugged in 3 pi over 2, it gave me 0. And when I plugged in 2 pi, it gave me 1. And it completely makes sense why cosine of 0 and cosine of 2 pi are the same values, because they are at the same spot. Now if I follow the pattern, let's look at the dots. It's going downwards and then up. So I'm going to go the opposite way. So on the left-hand side, I'm going to go downwards on this side and then upwards again. So let's go ahead and continue that pattern and connect our dots. And we have kind of like a squiggly W, if you want to put it that way. But as you can see, we still have a wave. Now it looks a little bit different from the sine wave, because notice that when you're at the origin, the cosine wave actually starts up at 1. In comparison to the sine wave, it actually started at 0. Now let's go ahead and take a look at negative cosine of x. So let's apply that same concept that I used with x squared and negative x squared. We applied it to the sine wave. Now we're going to go ahead and apply it to the cosine wave. So again, it says each of these points here will be multiplied by a -1. So if I were to take this 1 and I multiplied it by a -1, I would get a -1. So my new point, instead of being here, will be here. Now let's take a look at this one. This is a 0. If I were to multiply a -1 times a 0, well, by coincidence, I will still get a 0. So that point will still remain at that spot. Now I'm going to actually take this value here, which is a -1. If I were to multiply this -1 by the negative that's here, it will become a +1. So now this point has moved up to here. So if I continue doing that, I'm going to get the following flipped version, which is in orange. See, notice how I said that this point right here has now flipped and is gone down here. This point here has flipped and is gone up here. And notice what happened to this point. This is where both the black cosine wave and the orange cosine wave intersect, because it didn't change. Let's go ahead and look at the period. So in other words, if I start at the origin, I'm going to follow the pattern until I reach 1 again. And when I reach 1, I know what's going to happen again. It's going to follow the same pattern where it starts going down and then back up again. So at that point on the x-axis, that is what my period will be. Remember, the period is the point where it starts repeating itself. So in other words, it starts repeating itself at 2 pi. So the period for cosine is going to be 2 pi. Now let's look at the range. Look at the range and tell me. It's living between -1 and +1, because range is the y-axis. So again, they share the same cosine shares the same characteristics as sine. The period is 2 pi, and the range is going to be from -1 to +1. Okay, this is a generic formula that you are going to be using these next couple of days. I'm going to go ahead and go over it, and we'll probably practice it when I come back on Friday. So go ahead and take a couple of seconds to copy this down, the period, amplitude, vertical, and horizontal phase shifts of sine and cosine. Okay, y is equal to Vs is your vertical shift. The vertical shift helps us to determine if we are going to move it up or down. So in other words, if it's a plus or if it's a positive number, we're going to move it up. If it's a negative number, we're going to move it down. Plus or minus A. A is the amplitude. Amplitude is a fancy word for height. Amplitude tells us how tall a wave is. Let me ask you another question. Can height, if I were to ask you, what is your height? Some of you all would tell me you're 5'10", you're 6'2". But one thing that we do know about height is that it can never be what? Some of y'all may have answered it can never be 0. Well, that's true. It can never be 0, but most importantly, it can never be negative. Amplitude can never be negative. So always connect amplitude with height, and you know that height can never be negative. Now this is going to be for sine or cosine. This doesn't mean division. This is just me denoting that it's going to be either sine or a cosine trig that you're going to see. The n is used to help us find the period. Notice here that the n is whatever is factored out. Inside here, x minus hs. Hs stands for horizontal shift. That's going to tell us if we're moving left and right. Now in Algebra 2, when you did transformations, you should have been careful with horizontal shifts because every time it's inside with the x, it always tells you to do the opposite. So for example, if you see a -3, that really tells you to move the opposite direction. So if you think in your mind -3 means left, you actually got to think differently. That's going to tell you actually, no, we're not going to move left, we're going to move to the right. If you see a +3, that means you're actually going to move to the left direction. And again, we're going to practice some of these when I come back. Now, most importantly here is the period formula. Only for sine and cosine is the period formula equal to 2 pi n. 2 pi over n. Now let's take a look at here. The reason why n is here is because sometimes, and you will see later on when we do some exercises, is that x always has to have a coefficient of 1. Look at the generic formula. You don't see it, but it's right there, correct? This x has a coefficient of 1. If it doesn't have a coefficient of 1, you're going to need to factor, and when you factor that number out over here, it becomes your n. After it becomes your n, then you'll be able to take it here to the formula and plug it in, and you'll get 2 pi over whatever number that is, and that will give you your period. Remember what we said about period. Period is the point at which your wave starts repeating. Again, we will practice more of these when I come back on Friday. This is a tougher section, so that's why in regards to the homework, I'm going to take it slow and play it by ear in regards to turning it in. So again, period is equal to 2 pi over n. The generic formula is vertical shift plus or minus a for amplitude, which is always positive, sine or cosine, depending on which one is there, n times x minus hs, horizontal shift, but you got to think the opposite. If it's a minus, that really means positive, so you're going to the right direction. If it's a positive, that really means negative, so you're going to the left direction. So with that said, for those of you all that are done copying this slide down, go ahead and pull out your homework number 3. I'm going to do 3 problems with you. And then from there, that should